Hello science fans and welcome to SHE-ensya. Why is coffee so delicious? Can coffee really make us smarter or burn fat faster? What are the actual health benefits of drinking coffee? And why is coffee so addicting? Why do we ask questions? The SHE-ensya Why series will dissect some of our most head-scratching who, what, where, when, and why questions, teasing out the scientific principles from historical records, conspiracy theories, and mass media. Join us in today's episode where we ask the question, why coffee? The alluring nature of coffee is because of its organoleptic characteristics.
NANI?!
And when we say organoleptic properties, what we mean would be its aroma, texture, notes, taste, caffeine content, and more. There is a huge variety of factors that can lead to a good or bad cup of coffee, starting with the coffee plant itself. The tasty properties of coffee is a balance of genetics and the environment. After all, the genes and the coffee plant itself represent the recipes that create the proteins that can make a coffee taste good or bad. But environmental signals ranging from temperature, soil nutrition, humidity, availability of water, and more trigger the production of unique sets of proteins. Or the environment can also induce mutations or changes in the DNA that can affect the coffee plant's ability to survive, grow, or even taste. The genes in a coffee plant define the recipes or protein conformations that the coffee plant can have. But how much of these proteins are expressed and the minor variations in their structure are largely affected by the environment. And if you want to learn more about the interplay between the DNA and the environment that affects coffee taste, please watch the video that will pop up over here at the end of this one. Now combine the interplay of the environment and the DNA with post-harvest processing, you'll end up with a large variety of coffee quality and taste. But what makes for a good cup of coffee? Well, maybe science has the answer. We can first look at the 1,000 or so different chemicals found in a cup of coffee. But rather than watch a potentially 24-hour-long video, let's focus on the chemical big hitters. Now, thanks to coffee drinking, caffeine is one of the most widely consumed psychoactive drugs worldwide. And by psychoactive, we mean that caffeine can actually help improve our perception, increase our ability to stay awake and alert, and maybe even improve long-term memory. It is believed to work this way by blocking the receptors for the neurotransmitter called adenosine, increasing excitability of our brain. You see, in normal conditions, adenosine is the neurotransmitter that makes us feel tired and sleepy. It slows down the activity of our brain as it increases in concentration per hour that we stay awake. Now, in addition to waking us up, caffeine is linked to boosting metabolic rate and energy expenditure. And one reason for this is how coffee can trigger thermogenesis. Thermogenesis is used to describe a process of heat generation in our bodies as a direct and primary product of metabolism. For example, whenever we overeat, our bodies compensate by producing more heat. And in the process, it helps to burn just a little bit more of our fat storage. Now, studies indicate that drinking coffee can trigger thermogenesis without the excess caloric intake. So this could be responsible for the moderate boosts in metabolic energy that we experience after drinking a cup of coffee. But since coffee is often taken with sugar, cream, milk, or even a donut, then it doesn't really cause a significant weight loss. Now, current dietary recommendations suggest that up to 400 milligrams of caffeine a day can be part of a healthy diet. And that's about 3 to 5 cups of coffee depending on the brew. More than that can cause anxiety, restlessness, irritability, fast heartbeat, and muscle tremors. And these side effects are related to a lesser sensitivity to the restful hormone adenosine, but also to a reduced production of serotonin. It has been previously reported that caffeine has the capability to reduce the production of serotonin by our brains. And serotonin is the key hormone that stabilizes our mood and promotes the feeling of well-being and even happiness. And so, decreased production of serotonin can lead to depression, anxiety, and stress. Now, another interesting component of coffee would be chlorogenic acids, and around 45 types of these have been found in coffee. Chlorogenic acid appears to strongly affect the taste of coffee, such as its astringent, sweet, or sour notes, depending on its concentration. It is also considered to be the origin of the unpleasant complex taste found after prolonged brewing. But despite this, chlorogenic acid is considered to be a desirable compound because of the health benefits of its partially broken down version, caffeic acid. Like many other polyphenols, caffeic acid is an antioxidant, and this means it can slow down the effect of stress by fighting back against free radicals. And several studies have also shown that it has anti-inflammatory and antibacterial properties. Trigonoline, on the other hand, is that bitter chemical in coffee which serves to produce important aroma compounds. During roasting, trigonoline is partially degraded into nicotinic acid in pyridines, and that's why a very dark roast will only have a fraction of its original trigonoline content. Nicotinic acid is also known as vitamin B3 or niacin, and it is produced by changes in conformation of trigonoline at temperatures above 160 to 230 degrees Celsius. Niacin is a vitamin used by your body to help turn food into energy, so it is important to help convert carbohydrates and fats into energy that we can use. And finally, we have kaweol and cafestol, which are chemicals called diterpenes. And extracts of these almost twin molecules have been shown to have the ability to reduce inflammation, protect the liver, and also have anti-cancer and anti-diabetes properties. Now, these compounds vary in amounts in different coffee species and varieties. Though there are around 70 types of flowering plants that can produce coffee beans, two have the lion's share of the coffee market, Coffea arabica and Coffea canephora var robusta. In the Philippines, we also have our unique Barako blend that comes from the type called Liberica. And the type of bean, or even where they're grown, can affect the amount of compounds that make them taste different. Arabica is the most common bean, noted for its aroma and balanced flavors. Arabica tends to have more trigonoline, kaweol, and cafestol. Robusta beans, on the other hand, tend to have more caffeine and chlorogenic acids. Our Liberica coffee beans, on the other hand, are much larger than the more popular Arabica and Robusta beans, but it has the lowest caffeine concentration compared to other varieties. The roast can also affect the taste of coffee, but there is a huge variety of firing up the beans, and there is no standardized method for declaring whether it's light, medium, or dark roast. But generally, beans are baked somewhere between 180 and 250 degrees Celsius for somewhere between 2 and 25 minutes. This process takes beautiful green beans that usually have a mild bean-like smell and turns them into these aromatic, delicious, toasty brown beans. During the scorch, sugars and fats degrade. Amino acids and sugars react with each other, and the degradation of products spark chain reactions. This all culminates in the formation of about a dozen aromatic compounds that make up that enticing coffee bouquet. And finally, the grinding and brewing can also affect the taste of your cup. For the grinding, there's this fast and loose rule that the more you grind them, the more extracts you can get. In one study, for example, researchers found that using a standard home grinder for 42 seconds compared with 5 seconds doubled the amount of caffeine squeezed out of a 37-gram portion of coffee beans. But brewing methods are also critical for squeezing out all the goodness from coffee beans. Basically, there are three factors that determine how much you'll get out of your beans: pressure, time, and turbulence during the extraction. Espresso machines force hot, pressurized water evenly on fine, well-packed coffee grinds. And this produces brews that have the highest concentrations of caffeine per dose. But for more caffeine for your buck, you might want to go with quantity over espresso quality. Because a study that has shown beans packed in a regular drip coffee machine can produce half the concentration of caffeine, but the larger volume more than compensates for the amount that you drink. The same was true for chlorogenic acids. They're more concentrated in a tiny espresso shot, but an 8-ounce serving of drip coffee will deliver more of the beneficial compounds. As for taste, researchers have found that espresso brews have some of the richest flavors and creamiest textures, owing to that layer of emulsified oil that form a foam on top of the liquid. These oils are likely cut down in drip coffee thanks to the paper filters used, but may remain in boiled or steeped coffees. And lastly, after you've made that perfect healthy cup of coffee, please slow down with the additives. Because although coffee in itself is a healthy, low-calorie drink, adding sugar, cream, or milk will certainly nullify that. And so science has spoken. Coffee is made delicious by the different chemical compounds coded for by its DNA and present in its beans that are roasted, ground, and brewed. Coffee can help us feel more alert by blocking the receptors for sleep hormones. It can also help improve our metabolism by promoting the burning of fat. But overconsumption can lead to anxiety and paranoia because of how it dampens the production of serotonin. And coffee is a low-calorie drink rich in antioxidants and chemical compounds that reduce inflammation, have antibiotic properties, and can also help prevent cancer and diabetes. But why is coffee so addicting? Well, coffee is addictive because of caffeine and how it is basically a drug that affects the human brain and produces the alert feeling that people crave. And the more we drink coffee, the more our brain's chemistry and physical characteristics would change. And this is how tolerance to caffeine develops, because drinking more coffee would lead to the brain creating more adenosine receptors. So it would then take more caffeine to block out the greater number of receptors in order to create that alert desired effect. So in all things, please practice moderation. I hope you were able to learn something from our short video. If you did, I hope you can give this video a thumbs up and also subscribe to our channel. If you have any comments, questions, or suggestions, please don't hesitate to message me, your resident Filipino scientist, in the comments section below. Thank you very much, and see you around!